Hi, my name is Molly Jackson, and my project is a self-balancing robot. In this presentation, I will be covering the following. What is a self-balancing robot? What is a closed-loop system? What is PID? What is the robot made out of? And what does it look like in action? So what is a self-balancing robot? A self-balancing robot is exactly its name. It's a robot or vehicle that balances itself. A self-balancing robot uses a closed-loop control feedback to constantly adjust its position so that it stays upright and moves without falling over. Here's an example of the built robot balancing on its own two wheels. So now, what is a closed-loop system? A closed-loop control system is a control loop that uses feedback to control the output of a system that changes over time. A PID controller is an example of an instrument or tool that uses a closed-loop feedback to control variables and steer them towards a target value or level. There are some terms you need to know. One of them would be a process value / variable, which is what is being controlled. The other really integral thing to know is a set point, the desired value for the process value. A PID controller is probably the most widely used control system. The best way to explain this system is with a familiar example, a thermostat. Imagine you want your room to be 70 degrees Fahrenheit. That is your set point. However, it is currently 72 degrees Fahrenheit since the sun came out. The PID control system's algorithm will read the sensors and provide constant feedback to decrease the temperature in the room by driving the AC. In the case of the robot, we can say that one of our process variables is balance, and the set point is a value that keeps it upright. So how does it do that? PID is actually an acronym. Each letter stands for a different control mode: proportional, integral, and derivative control mode. These terms may sound familiar to those of you who have taken a calculus class, and yes, they are quite similar. Each control mode aids in compensating for any changes in the system. They work in tandem to create an effective control system that accounts for error and is accurate. First, the proportional control mode. This control mode works on the difference between the set point and the process value. However, once the difference between the two reaches 0, the target value becomes impossible to reach. Integral mode. Since the proportional mode cannot reach the target value ever, the integral mode will sum the error over time to account for it. However, this will cause an overshoot. Lastly, the derivative mode will account for the overshoot and rapid increase by calculating the rate of change of the process value. Here's a diagram explaining how PID controllers work. It's as I mentioned, you have a process variable and you apply each mode to get it as close as possible to the desired set point. So what is this robot made out of? This robot, which is built from the Tumbler kit, is made up of some significant components such as the GY521 board, ultrasonic sensors, TV6612 FNG, and the Arduino Nano board. The GY521 board is actually a module that has a gyroscope, an accelerometer, a temperature sensor, and a digital motion processor. This is an example of something that the PID controller works with. Since the robot rotates, the gyroscope has to constantly have a feedback loop applied to it to have it move as intended. The ultrasonic sensors measure how far something is, such as a target, using ultrasonic sound waves. This is used in one of the function modes where the robot follows a target. The TV6612 FNG is a dual motor driver for interfacing DC motors. And as for the Arduino Nano, it is a very versatile board that can be programmed using the Arduino IDE. In this case, the robot was programmed using Arduino, and examples of the given code will be shown in the next slide. Here's an example of code that helps make the robot work. This is setting some variables to have certain values, such as balance, speed, and turn. Additionally, this is an image from the manual that shows what the components look like, and then the other image is of the kit's application for remote control use of the robot. So really, how does the robot work? This self-balancing robot works with a few function modes that tell it what to do. This video will showcase the modes and demonstrate a PID controller in action. The robot's modes can be changed with a button on its front, but for this video, I use the application to control it.